Hello friends, this is Introduction 1.3. In this lecture, I will deal with the syllabus of Soil and Water Conservation Engineering and Irrigation Engineering. In the Intro 1.2, we have already dealt with the syllabus of farm machinery and power. So let's start. Here we will see syllabus at a glance. This is me, got rank 1 in 2013 and did my MTech in farm machinery and power from IIT Kharagpur. So the first book which I will be dealing with is the Soil Mechanics. So this is the syllabus for GATE which you can cover from this book. So in starting I would like to say you that please sit with one paper and pen, and I will also say that these are the books which I referred during my preparation. So if you are using any other book, that is also fine. So let's see the first. Engineering properties of soil. So what are the engineering properties? Like the density of soil, porosity, void ratio. These are known as the engineering properties of soil, which are used to determine the specific parameter for specific uses. If you will, so you have to study about their definition, symbol used for them, and their interrelationship. Like if you will denote porosity by N and void ratio by E, then what is the relation between porosity and void ratio? It is N equal to E divided by 1 plus E. Means porosity is equal to void ratio divided by 1 plus void ratio. So like this you have to study and memorize your formulas. Okay. Then what is the index property of soil? See, what is index? Index don't have any unit. So we define certain properties of soil which don't have any unit. So those properties are known as the index property of soil, like plasticity index, like shrinkage index. So there are 4 or 5 type of indexes which you can study. If you have properly understood the engineering properties and their relationship, then the index property is nothing else but application of those properties. Okay, so make sure you understood these 3 things first very well. After that, permeability and seepage analysis. So when you heard the word permeability and seepage, immediately it should come to your mind that permeability is the vertical flow of water into the soil mass, while the seepage is the lateral flow. So this much clarity should be there in your mind first. Then what after? So what is the unit of permeability? It is meter per second. So what are the various factors which affect the permeability? Is temperature affect? Is soil condition affect? So these are the theoretical aspects which you must learn about this type of things. Other than this, one important aspect is quicksand condition. So you read from this book what is quicksand condition. Also there is horizontal permeability as well as vertical permeability. One formula is there so that you can see that formula in the book, because in past year questions directly have come based on that formula. Next, here is strength and Mohr circles of stress. From these two topics, no question has come till date, so give it less weightage in your preparation, even though you need to understand both of these, so that it will be easy to understand the other properties. Now we come to the active and passive earth pressure. So whenever you see the term active means away from the wall. So active pressure acts away from the wall, while passive pressure acts towards the wall. So in objective type question they may ask which type of pressure acts away from the soil condition. Option A, B, C, D they will give. So you have to take active pressure acts away from the wall. Similarly, there is one pressure known as the earth pressure at rest. So you have to learn what is the relationship between active pressure, passive pressure and pressure at rest, which is the higher value and which is the lower value. That will suffice regarding this topic. You don't have to go too much into the detail. In this book also you will find lots of complicated numericals and lots of problems. You don't go too much into detail. You just make sure you know what is this pressure, what is the formula of this pressure, and what is the relationship among them. That's all. In stability of soap, no question has come till date from this topic, but I personally feel that you should know what is the Taylor stability number and what are the types of stability in soil mass. Other than this, from this book you can study about the aquifers. This is the very important topic. Now, the confined and unconfined aquifer I will cover in the upcoming videos with greater detail and numerical problems. And you can also study by yourself, otherwise you can watch the videos later. Now we move towards the second book, that is the Fluid Mechanics by R.K. Bansal. In this many chapters you have to cover from this book. This book has been written in very simple language so you can understand by yourself. See, first topic is ideal and real fluid. They are some kind of theoretical concepts. I think you all know that what is ideal fluid, which don't have any viscosity, where friction is zero. But they do not exist in the real world. What exists in the real world is the real fluid, which have the viscosity. Okay, so now second point is the properties of fluid. Properties of fluid means you need to understand what fluid acts when it interacts with the other medium or when it is kept at rest. Like when a fluid is there in a confined medium, then it acts pressure equally in the all directions. You need to understand what is viscosity, and viscosity is of two types. One is kinematic viscosity and second is dynamic viscosity. And what is the relationship between them? Like mm, nu equal to mu by rho, where mu is the dynamic viscosity and mu is the kinematic viscosity. And also make sure when you remember this type of formula, you also know the units of them, because unit plays a very important role while solving any numerical problem. And other properties are like shear strength, shear stress, like this. Second is the hydrostatic pressure and its measurement. So hydrostatic pressure, one instrument is there which is known as the U-tube manometer. So you solve just 2 or 3 problems based on the U-tube manometer, because sometimes they will give you one picture of manometer and 2-3 points they will locate and they will tell you to find out the flow pressure at particular location. So you should know about this. This hydrostatic forces on planes and curved surface, this is also under the syllabus, but I have cut it because no question have been asked from this topic, and you really don't need to worry about this topic. You can leave it. Second comes the continuity equation and Bernoulli's theorem. I think you all know that continuity equation is A1V1 equal to A2V2. So you can use this equation. This is very useful equation. And second comes Bernoulli's theorem. In Bernoulli's theorem, you need to remember the formula of Bernoulli's theorem. What are the various pressure gradients, like B1 square divided by 2G plus E divided by rho G plus Z equal to constant. So what did denote? V1 square divided by 2G. This is the velocity head, plus T divided by rho G. This is the pressure head, plus Z. This is the potential head. So you need to understand each term, why they are there. And certain instruments are there which work based on the principle of Bernoulli, like venturimeter or fish meter. So in 1 mark question they will give which one of the following instruments work based on the principle of Bernoulli. So you need to mark that instrument which works on that principle. So you study based on that. Second comes the laminar and turbulent flow. Don't confuse laminar and turbulent flow in pipes and laminar flow in soil mass, because the Reynolds number for laminar flow in pipe is less than 2300, while it is less than 1 in case of the soil mass. So you should remember this distinction. Don't get confused. Okay. Second comes the Darcy-Weisbach formula and the Hazen-Williams equation. These two equations are also very important because from Darcy very question comes year by year. Moody's diagram is not that much important, but you can see what this graph shows. It shows that frictional loss in a pipe. You can just Google it, what is Moody's diagram. Don't go too much into detail. And these last two topics are very important: flow through orifice and notches, and flow in open channel. Make sure you know what are the various type of orifice, like circular shape, rectangular shape, square shape. What are the different type of notches, like triangular, right, trapezoidal, and their formula. Their formulas are, in one look they will look too large in size, but they are very important. You should know them. Then again comes the flow in open channel. Flow in open channel, this topic is very important from the hydrology as well as from fluid point of view. In this, you need to know the difference between pipe and open channel. What is the value of Reynolds number in open channel? Why they call it the open channel? And the concept of specific energy. In this book, one chapter is there that named itself is flow in open channel. You can see that chapter. In this lecture, in the upcoming lecture, I will deal with the most economical section, that is also part of flow in open channel. You can see on that video. One more important point, in this book you will get the chapter on pumps. So basically two type of pumps, like centrifugal pump and reciprocating pump. So you give more emphasis on these two type of pumps. In reciprocating pump, you study both single acting as well as double acting, their formula and some numerical based on that formula, because year by year they ask this type of question. So if you study this much from this book, that will suffice, because this book is also very thick, and lot many chapters are not of our concern. They are concern of civil engineering students. They also read this same book, but you don't need to go into that much detail. You restrict yourself with the syllabus of this many. So I think I explained this syllabus into too much detail. In the next video, I will explain the syllabus of hydrology and soil and water conservation engineering, and maybe irrigation engineering. Thank you. Thanks for watching this video. If you like the video, please do share and subscribe. Thank you.